guys, welcome back to our another video. So now in this video we will discuss about another program which is print increasing using recursion. Okay, so let's start. What is our input? Input as a n. So input will be n. Okay, so if we assign the value of n will be like 6. So what will be our required output? Required output will be like from 1 to 6. 1, 2, 3, 4, 5 and 6. This will be our required output. And what will be the structure of our function? This will be function pi print increasing function, then call n body start body close, and we will call print increasing function. Here we will pass the value of n, that is a 6, and the body of this function we will write it later. We will implement the code here later on. Okay, so now we will solve this program using our approaches which we mentioned in previous video. So first approach will be high level approach. Okay, inside high level approach, the first one is expectation. Inside expectation, what actually we want to print? So we want pi of 6, which we need to print from 1 to 6. Okay, and now in the second step we will assume that the pi of n minus 1, here 6 is n and here n minus 1, which is pi of 5 will print from 1 to 5 automatically. We don't need to think about this step because we are only assuming this step. So now we will go inside the third one. Here we will relate our expectation to assumption. So what we need to do here, we just, as we see there, if we call pi of n minus 1, which is pi of 5, okay, it will print from 1 to 5. And what we rest, actually we just rest only a single step, that is a 6. So here we will print of n. What is n? N is 6. So now we get our desired output. So what is the statement here which we implement in our code? That is firstly we have to call a pi print increasing of n minus 1 and then console n. Okay, so now we will implement our low level analysis, low level approach. So low level approach, we will implement our logic. Okay, so here what we will write, we will make a function of pi where we will pass n as a parameter, and then open the body of function, then here we will close it and then call a pi of n, which is 6 probably, yeah, which is 6. Okay, so now what will be the next step? Next step will be pi of n minus 1. So here we will call pi of n minus 1. Okay, and then after that we will print the n. So here we will console.log n, right? So now in low level approach we will get into second step, that is a dry run or backtracking. Okay, inside backtracking we'll make a stack. Okay, here this is our stack, and here we pass the value of n as a 6. So here pi of 6, then what will be the value of n will n, that will be 6. Here it will be 6, and then call pi again. Pi again will be now n minus 1. This will be like pi of 5, right? And what will be now the value of n? This will be 5, and then again here it is n equals to 5, then it will come to this line, and now it will be like n minus 1, it will be 4. So it will call pi of 4. Now here the value of n will be 4. Now pi of, it will repeat again and again, so it will call for pi of 3, then pi of 2, then pi of 1, and then again pi of 0. We should mind here, like we don't need to 0. If the value of n will be 0, then later on it will print 0. So we don't require 0. We only need to print from 6 to 1. So here we have to consider that this is our breakpoint or base case, right? So we have to break our program on pi of 0. So here we have to write a restriction or condition where n will be less than or equals to 0, then it will return only. It will return only. Okay. Otherwise, it will execute this line of code, these line of code. Now our program is ready. So what is our program? Our program is this much only. Okay. And but here we can see that there is nothing which we print here. So now what will be here, we can notice that when we execute the R code, the control was only over here at that point of time. Okay, so now our second line of code will be executed now. Okay, so when we execute this function pi of n minus 1, the stack execute from bottom to top. Okay, but now after this function, the next line will execute. Then the stack will go from top to bottom, right? We should notice this. So here one more thing which we need to pay attention on here, like the code which is the calling function, this one pi, the code which is above of this function will execute during when we execute the stack from bottom to top. Okay, when we execute bottom to top, then this code, this line of code which is the above of that particular calling function will be executed, and when we back from top to bottom, then after those codes which is after that particular calling function will execute. So now what will be here, it will wipe out because 0, we restricted the condition for 0, and it will come here in this line. Over here the value of n will be 1, so console 1, so console n, it will print 1, and then again it will go, these line will be, these memory will be wipe out from a stack, and then it will go little down and call pi of 2. So here the value of n is 2, so now it will console 2 again, and again it will call a pi of 3. Then for a pi of 3, the pi of 3, the value of n will be 3. So now it will print 3, and this will also wipe out. And again for a 4, this will wipe out and print a 4, and this and for 5 it will print 5 and then wipe out, and for a 6 it will print a 6 and then wipe out. So all our stack will be empty. In the end it will be empty. Okay, and this is our desired output which we need to print. And our whole logic of our function is inside this block. Okay, we will see the live implementation using VS Code, right? So here this is our function print increasing. Here this is our function print increasing. Here we pass n as a parameter, and this is a body of our function. Or here we call a function and pass the value 6 as a n. Now we will write a condition here, these lines. So here we will write if n is less than or equals to 0, return nothing. Return nothing. Otherwise call print increasing function of n minus 1, right? And then console dot log n. Now our program is ready. So we will execute our program. So here this is our required output 1 2 3 4 5 6. Okay, so this is our whole program. In our next video we will meet with a new problem statement and resolve it. Okay, till then take care and bye bye. I will provide the link for source code of this solution, so you can go through our link which will be in description and get the code.